Welcome back. This is going to be an additional example where we will be asked to find a current, or actually a few different currents, in our very first circuit schematic. So here is a very simple circuit schematic, and you will notice that we have some symbols here which we have not fully understood yet. So let me take a minute to explain them. This circle that you see here with the arrow in it actually signifies a current source. What is a current source? This is something we're going to discuss later on, but essentially a current source is a device that outputs in the circuit a specific amount of current. In this case is given as 5 amps, and the arrow you will see inside the circle is essentially the current flow direction. So we have 3 of those current sources. There is a 5 amp current source that you can imagine that as shooting current upwards. There is a 2 amp current source that results in a downward current, and there is another downward current whose value is 3 amps. We also have 2 devices shown with these rectangles here. We don't really know what these devices are. They could be really anything. However, really doesn't matter. The main question that we want to answer here is how much current flows through these devices and how much is also this current I2. Now, a lot of times in this class, you will be asked to find current. People will say, how much is the current that flows through this device A, or how much is the current that flows through this device B? The very first thing that you will have to do, and I have already done this here for you, is to put down a direction for the unknown current. It's actually impossible to find the current that you need unless the direction is assumed. For example, here I have assumed the direction for I1 to the right. I have assumed the direction of I3 to the left, and I have assumed the direction of I2 downwards. Sometimes you will already know the direction, so you will not have to assume it. But most of the times, whenever you're solving a circuit, the direction of the current will be unknown. So the natural fear that a lot of students that are starting this class have is, my gosh, what happens if I assume the wrong direction? Or they spend too much time trying to guess what the right direction is because they think that by guessing the right direction will actually simplify the problem. The reality is that you don't have to spend any time on this. Just go ahead and assume a direction, solve the problem, and if the result is negative, it simply means that the direction is the opposite of what you had assumed. For example, if we assume the direction I1 is shown here, and let's say another student had assumed the opposite direction for I1, the result for the student with the green arrow would have been the negative of the result with the student with the red arrow. So again, you really do not have to spend the time thinking of what the right direction is. Go ahead and assume one, stay with that, and at the end of the day, you will know exactly the value. So let's suppose that we assume the directions I1, I2, and I3, and let's see if we can find the values of those assumed currents. I'm going to start with the current I2 because that's probably the easiest one for you to see how much is the value. So I2 is really a downward current and is really the current that flows through the current source that has a value of 2 amps. So it really doesn't take much guessing to say that the current I2 will be equal to 2 amps. It's really the current that flows through this current source whose value is already known. In a similar way, we can start looking at currents I1 and I3. For example, if I look at this current I1, it really is nothing different than the current that actually comes out of this 5 amp current source. So if I look at this current I1, I will basically be able to write down that I1 is equal to 5 amps. In a very similar way, I can think about I3. Now, I3 is really the current that will flow from the 3 amp current source, but if you pay attention to the direction, it's actually in the opposite direction of 3 amps. So that means that I3 will be equal to negative 3 amps. So this is really the end of this example. We were able to find correctly the values of I1, I2, and I3. And again, I want to make sure that from this early point in the class, that when people ask you to find the current, you probably have to assume a direction, and you don't have to spend too much time thinking of the direction. Just assume one and find the value. If the result is negative, like for example is in the I3, it simply means that the true current is the opposite of what you assumed. So thank you. We'll see you next time.